Topic 4, congruence. Congruent. When you have things that are congruent, they are exactly the same. So for two figures, see how all the sides are exactly the same tick marks, and all the angles. So this definition says two figures are congruent if they have the same shape and size, but they have to all be the same. All the side lengths and all the angles have to be identical to the matching or congruent parts. So those three triangles are congruent, and you could do like a reflection to show congruence where they map onto each other like that, or like a rotation or a translation. Any of those rigid motions will be able to map the other one on to the original. Rigid motion, that's just what I was talking about. So rigid motion are those three things that move without changing the shape or size of the triangle. So reflection, rotation, and translation. Isosceles triangle. Normally it looks like this. That's like the generic, these two sides are the same. So there's something you need to know about isosceles. In addition to the two sides being the same, the two base angles will be the same or congruent. Base angles of an isosceles triangle. You can use this rule in a proof. And basically, if you know a triangle is an isosceles triangle, then you also know that the base angles are congruent. So if it's isosceles, then the base angles of the isosceles triangle are congruent. Vertex angle, we don't talk about this as much, but the vertex angle is where the two congruent sides of an isosceles triangle come together. So those two congruent sides come together and they create this vertex angle. So that point, not the two congruent angles, it's the other one, where the two legs that are the same come together. That is the vertex angle. Equilateral, equal, and then lateral means the sides. So equal sides, it's a triangle that looks perfect, like the perfect triangle. It's a regular triangle. It's where all the sides are congruent. And since all the sides are congruent, all the angles are congruent. Now, you need to remember that equilateral triangles are 60-degree angles. But if you forget, just take 180. All triangles add up to 180, the interior angles, and then divide by 3 because they're three of the same. So 180 divided by 3 is 60 degrees. Equiangular, here's equal angles. So it's a triangle or shape with equal angles. Since we're talking about triangles, we're going to look at this. So if this is an equiangular triangle, I'm hoping that you can see by the converse of equilateral triangles that if all the angles are the same or congruent, then all the side lengths would also be the same. So it works both ways. Perpendicular bisector. Okay, perpendicular is when they meet at a 90-degree angle, perfect 90-degree angle, and bisector is when you take something and cut it exactly in half. So put those two together. You are going to have a segment or line or even a plane cut something exactly in half. So see, A to B was cut exactly in half at a 90-degree angle. So over here on this triangle, X to Y was cut exactly in half at a 90-degree angle. So this happens on triangles. It happens on figures. In the past, we just did it like on a segment, and we did a perpendicular bisector on a segment. Well, here it is on a triangle or triangles. Right triangle. You've learned about this years ago, hopefully. A right triangle is a triangle with one right angle or 90-degree angle. So it looks like this. It's the only triangle that has a hypotenuse. And the hypotenuse is always C. We consider it C. That's what we name it. Like the Pythagorean theorem, a squared plus b squared equals c squared, where c had to be the hypotenuse, and it's always the one that does not touch the 90. So that's a right triangle. Side, angle, side. We're going to go over the rules that prove triangles are congruent. Now, the reality is there are 5 rules that prove triangles are congruent. If you do not know those 5 rules, then what you would have to do, you would have to prove that every single side and every single angle of one triangle equals every single side and every single angle of another triangle. But you don't want to do that. You don't want to prove that every angle and every side. That would be proving 6 things, all 3 angles, all 3 sides. These are shortcuts. So the first shortcut, side, angle, side. So what that means, and here's a picture, if you have a side, an angle, and a side congruent to a side, angle, and side of another triangle, then that is a rule that you can use to prove the triangles are congruent. Angle, side, angle. Same idea as the one before, but you're going to have an angle, a side in between it, and another angle. Having the two angles and then that side, the in-between side, it's really important that the side is in between those two angles. It doesn't count if it's somewhere else, not for this rule. Angle, side, angle, the order matters. The side has to be in the middle. Side, side, side. That's pretty obvious, I hope. All three sides are congruent to all three sides of another. So here's an example. And if I move this, again, those rigid transformations, if I just translated it, it would map one triangle onto the other just by a rigid motion. So those are congruent by side, side, side. And angle, angle, side. Notice the order. The two angles have to be together, and then the side has to come after it, not between the two angles. So angle, angle, and then this side. If this side was marked, it would be angle, side, angle. But it's not, so it's angle, angle, side. If you have two triangles that have congruent angle, angle, and sides, then the whole triangles are congruent. Now this one, hypotenuse leg, it works only with right triangles. Hence hypotenuse, those are only on right triangles. So hypotenuse leg theorem says if you have a right triangle and the hypotenuse of one is congruent to the other, and the leg of one triangle is congruent to another triangle, then this entire set of triangles are congruent. So it has to be a right triangle, and then it's hypotenuse leg, or HL. So what rules can prove triangles are congruent? Remember, there are only 5. I just went over them. So let's list them. See if you can remember. Side, 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 angle, side, angle, side, angle, 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 side, and HL. If you are trying to prove triangles are congruent and any other thing works, like it's not one of these, then you have not proven that they are congruent. You have to use one of these 5 rules, or you have to prove that all the sides and all the angles are congruent, which is just an extensively long proof. So use these shortcuts. If there's any other version of these letters, it will not work. Okay, and I have some blank slides for you if you want to make your own. I hope these help. Enjoy working on those flashcards.